Empirical formula problem. We're going to follow the same protocol, grams of each element, moles of each element, mole ratio. In this case, we're given the amount of each element in percentages. So if we assume we have 100 grams of the compound, our percentages are automatically converted to grams. So we now know how many grams of each element we have. We can convert to moles by using our atomic weights of carbon, oxygen, and magnesium as conversion factors. In each case, we're going to end up dividing by the atomic weight to give us moles of each element. We do these problems in our calculator, and we result with 1.19 moles carbon, 3.59 moles oxygen, and 1.19 moles of magnesium. It looks like a 1 to 3 to 1 ratio, but let's pretend that wasn't obvious. We can get our mole-to-mole ratio by dividing by the least number of moles. That results in a 1.0 to 3.0 to 1.0 mole ratio, which means we have carbon 1, oxygen 3, magnesium 1. This is not an appropriate order to write a chemical formula. We write metals before nonmetals. So if we write the metal first, we see that our compound is magnesium carbonate.